Questions about the topics we've talked about last time, which are pointers and arrays and things like that. Any questions on those? Suggestions? Objections? Good? All right. So let's start the session by creating a new project. Empty project. And we're going to go to our directory. Again, this is what you should do every single time you're working. You go to your own repository. In the repository, you select where you want to do your work, and you create a new directory for it. For me, it's the date that I do it. Make sure this is always checked. Create. And 3 years later, a console application will get created. And in that console application, we are going to have View Solution Explorer. So we create a new application. Include IO stream using namespace std int main return 0. By the way, where that 0 goes when I say return 0? Who's receiving that 0? A function returns a value, right? Who's receiving that?
Console.
What's console?
Is it
New. Who receives that? Okay. So you know when you have a function, the function is being, so if I have something like this over here, and I write, right? Who's calling foo?
main?
So who's receiving foo? Main. Who's calling main?
OS. Operating system.
Operating system. Who's receiving the 0? Operating system. Thank you. So essentially, it just to show you, if I go over here, like I don't know, 1, 2, 3, 4, 5. Okay, if I actually do something like this, a program like this, and I compile this code, rebuild it so it compiles, right? And then I have to see where this program is. So I'm going to right-click over here. I'm going to say open folder in open folder in File Explorer. So I have the path for it. Then if I open the command line, in the command line, I'll go to that directory. In that directory, I have x64, I think that's the one, cd x64, I think that's the one. In that one, I have debug. And in that one, I have the executable. So if I say 05, January 20-something, and I hit enter, it executes, right? Now if I say over here, echo error level. Oh, level. What am I doing? Level. Arrow. There we go. That's 1, 2, 3, 4, 5. Okay? So that's being, why do they do that? Why do we do this? So you can send a message out to operating system. When you are running your submitter, when you submit your things using the program I wrote, you wrote tilde submit, right? How does it know that your compilation failed? It actually calls the compiler runs, and returns a value to operating system. It checks that value on the operating system. If it's not goody-goody, it tells you you had an error. Okay? So that's that. Something that you need to know. So the point that I want to make, any concept that you see is exactly what happens when you have a return statement, and return statement returns something somewhere. This is it's not there just for beauty. Okay, it actually works exactly the same way. So you can literally backtrack. So you could guess, and 99% of the time your guess is correct if you're following the exact pattern. Okay. Anyway, so that's that. So talking about what we dealt with last time, we talked about. So let me bring this. I'm going to copy those. Okay, and I'm going to quickly open what we've talked about and review it. Okay. Yes.
What is returned if the main function is void?
You can't.
Why?
Main is always integer. It's supposed to be an integer. That's the signature of main. Actually, that's not the signature of main. Main accepts some arguments too. Actually, 3 arguments. We'll talk about it in 3, 4, 5. So we'll talk about it in 3, 4, 5. So the real syntax of main is actually, the real syntax of main is this. That's the real syntax of main. Okay? So this tells when you're issuing the command how many things you have on the command line. So when I say 05 January 11 and I keep adding arguments like the commands that you do, that tells you how many are they. This tells you what are they, the things on the command line, and this tells you what are all the things set up in the operating system. Path, number of CPUs, username, home directory, everything gets passed. So you get those 3, 4, 5. Just for you to know, because you're asking, I'm not going to talk about it now. It's a kind of a thing that's what kind of things we'll talk about in 3, 4, 5. But that's 3, 4, 5. Are we okay? Okay. So let's go back to our quick review. We talked about variables and how we can actually set and initialize the variables. We said it's extremely important to understand that assignment at the moment of creation is not setting, it's initialization. It means the variable will come to life with 10 in it. But in setting, if you don't say anything, the value will be defaulted to whatever it is. If there is no defaulting set for it, it will be garbage in it, and then you overwrite the garbage. So this is initialization, this is setting. Then we talked about how functions are called in C language. We said in C language, when you make a function call, the arguments of the function are actually initialized by the values you pass to them. We do not have anything called pass by address in C language. It's a lie. In C language, everything is passed by value. That value may be address of something. Okay, so there is no pass by address. We don't have such a thing. In C++, we have only 2 things, pass by value, pass by reference. There is no pass by address. Pass by address is just a lie that we tell you to feel so you can sleep happy at night. Okay, everything is passed by value. Now that value could be address of something. Okay, settle that down in your minds from now on. So now in here, I am passing the value of a variable. So val will be initialized to that. When foo is done, val has a function scope. It dies. The next time foo is called, val will be initialized by 100, and it's done. And after that, it's going to be. So that was how functions called. We needed to know, and we talked. Then we talked about, my name is Fardat, call me Freddy. And I said Freddy is a new name, like a new name for Fardat, and called it alias and say, please don't call me that. It was just an example. Remember that? Okay, so that's that. So you can actually give new names for already existing things You can set new names for already existing things. And the new names you are creating over here will essentially become new handles for the things that you have. So you had a num, now you have after line 6, you cannot say which one is the original, n or num. They are both valid names for that piece of integer in memory. Are we all okay with that? Okay. And we said because of this beautiful fact, we can actually play tricks in calling functions. We said when we have a function, as we said, functions are always passed by value, always. If I put a value in here, I will be that value, and then whatever happens to I in the function, because it's a copy of num, nothing happens to num outside. And then we use the magic of aliases, and we said, and then we explained how we can pass that value, the address of the thing. So we can actually say the value I'm passing to foo is actually the address of the variable. Therefore, in there, I had to jump through hoops and say target of something and go through all that so to be able to change stuff. Still, this is passed by value. Okay? What is that value? An address. Okay? So the argument is always passed by value. But through that argument, I pass the address of num. So num is passed by address, but the argument itself is the value. And the value is an address. Are we all clear on this? Okay? I just want to make sure that you understand there is no such thing as passed by address. We don't have that. Okay? It's just a common mistake that we make. Okay? Everything's a value. That value could be an address. Now we move to C++ and we say, hey, now we introduce you for pass by reference. Well, pass by reference is essentially you are saying that I is a new name. And immediately we say, if there is an alias, it must be initialized. How come you didn't initialize it? And then we remember when the functions are called, the arguments of functions are initialized by what they are passed to. And because I'm saying num, because I'm saying integer reference I is num, I becomes a new reference to whatever that is passed, which is essentially the num out here. So when it goes up there, nothing new is created. I is just a new name for num. That's why I don't need to jump through hoops. Whatever I do to I, I'm doing it to num. And it doesn't have to be only that, which means remember I told you you can even initialize like this? Remember? We said we have a universal way of initialization. You put open curly bracket and you put a value in it, you can initialize it. It's the same thing as the top one. No difference. So you can initialize it. All of these work. On purpose, I write it in a different way just to introduce you to it. So, or let's do it like so. I can even do this. It's the same. No difference. They're all the same. Okay? So I'm going to put it in today's thing. No, that's not today's. This is today's. Okay, so when you put it over here, and you can actually say over here, foo, another value, and the function call to it will be, will be the same, which means when it's getting called, that reference is gone and dead. The new reference I in the second call will be the new name for another value. And therefore, foo can change another value too. Are we okay with this? All right. Running that, we said will actually work out. Okay. And now we do the reference, pass by reference, we talked about it. And then we talked about crazy reference. And I said, always when a definition comes out, and I'll keep mentioning it over and over, it applies to everything. Because functions can have types when they return something. That type might as well be a reference. Therefore, the entire function becomes new name of something. And this becomes something possible, which essentially I'm saying I'm receiving a reference from outside. And then foo becomes a reference of that one. And now, or you can do something like this. What does line 3 do? Line 3. It creates an integer. What that empty bracket does in front of it, do you remember? When we put an empty bracket, do you remember what it does? Do you remember what it does?
Pass.
Do you remember what it does? Pass? Okay, 3 passes we wait. Anybody remembers what that does? No, you don't need to pass it. Keep it. Does anybody know what that does? When you put empty bracket in front of anything, you're saying, asking compiler default it. Set it to its default value. If it's a primitive value, everything, all the bits inside become 0. So they become 0. You put it in front of a pointer, it becomes null pointer. You put it in front of an integer, it becomes 0. If you put it in front of a double, it becomes 0.00000. Everything will be 0. And later on, we're going to learn about structures and stuff. If you put it in front of a structure, it makes everything inside the structure 0. Okay, so if you have struct student and you have 50 things in there, and you say student, and then you say student S, and you put empty curly bracket in front of it, it makes everything inside that 0. Okay? So it's a global way of making 0. Anyways, so what I'm saying is that I can say integer get global. And in here I can say return global value. You see that? So you can actually now do this. I can actually say over here, get global is equal to 1, 2, 3, 4, 5. Whatever, 1, 3, 4, whatever the value is. Which means because get global is returning the reference of that global thing, you can actually set it to something. It's just a crazy thing, crazy examples, okay? So again, how can a function sit at the left side of an assignment? The only possible way is when they return a reference. Remember that. It's something that you have to remember. Question for your quiz. When a function can stand at left side of an assignment, and the answer for the quiz will be when it returns a reference. Because when it returns a reference, it becomes alias of something, and because it's alias of something, you can actually do something. We good to this? You're okay? All right, and after talking about all these things, now we said we are confused enough. Now we can actually start learning about dynamic memory allocation. We went through pointers and all the good stuff we had, so let me just open this. Existing, no. Existing type. Okay? I'm going to go through these things like lightning, okay? So be aware. What happened? Didn't work? It said add existing items. Okay, good. So all right. We said we have memory. We said when we create the variable goes somewhere in memory. We can put values inside variables using their names because that's how they are set. And we said we can actually create a pointer. The pointer's job is going to be to keeping the address of other things, and the address is supposed to be address of someplace valid. where we put the stuff in. We talked about to be able to get the address to be valid, we need an address of operator, and we need the target of operator to be able to indirectly access a pointer, access a variable using a pointer. Then we showed that we can actually use that pointer to access the variables, and if it prints the pointer out itself, it prints out the address of the variable, because pointer's job is to hold the address of the variable. And then we try to reuse that pointer to hold the address of another type, and we found out that our design is bad, because the pointer doesn't know what is the target of the address, therefore it is impossible to set it. Because of that fact, we added the type of the pointer in front of it. We said integer pointer, and then everything was good. Then we said double pointer, we said everything was good. And then we find out that all these things are already set in the language the way that a pointer is presented with an asterisk. And we said, whenever you are doing that, whenever you are putting an asterisk after a type, it becomes a pointer. And address of is represented with an ampersand. Whenever you see an address ampersand as a unary operator before a variable, it means address of, and that dictates that what you have in front of it is in fact a pointer. And target of is asterisk too, so if asterisk is used as a unary operator, again, it means what you have over there is a pointer, and it extracts, and you are actually saying, go to the address that the pointer is setting. So again, one more time, asterisk after the type, pointer, asterisk after a type, pointer, address of, you have a variable. It extracts the address, and what you have as at left is a pointer. Target of, whatever you have after, is a pointer. And we talked about how everything is actually created, as I mentioned right now. And that was it. Okay? Then we talked about pointers and arrays. And we said, we've been told that we have a variable. The variable has a name. We can actually use the variable to put stuff in it. And we create a pointer. It's still a variable. You can put stuff in it. There's no problem with it. But when we are talking about an array, the story is different. When you actually create an array, you're requesting the compiler to give you series of the same variable back to back. And we said that they told us the name of the variable dictates where the array is, and the index shows which one. But that's not what happens behind the scene, really. Behind the scene, what happens is that when you create an array, it actually creates that many variables for you. But the variables, they don't have a name. What it does, it creates a pointer with the same name as the name of the array, and uses that pointer by holding the address of the beginning of the array. And therefore, from there, it can access everything. So when you are saying 0, you are essentially telling, when you're saying index 0, you are essentially telling it, I want from address 108 goes 0 elements further. And each element is 4 bytes in this case. If you say AR1, you are saying go 1 element further. The size of the element is 4. That 1 means 4 bytes, therefore it jumps to the second one, and so on and so forth. And because of this fact, you can literally say target of AR, and because target of AR is the beginning, it actually means the first one. And when you say index 2, it means 2 integers further, which means 8, and it's going to go to the third element. You could have used the pointer notation for it, saying, I want 2 to be added to this address, therefore 2 integers, therefore 8 bytes, and then target of it will be the exact same thing as top. So this is called pointer notation for an array. This is index notation for an array. Potatoes, potatoes. They are the same. Okay? Lots of geeks used to do this just to show off that they know what arrays mean. They don't do it anymore because it makes your code unreadable. You don't want that. You want the code to be readable. The time passed. It used to be programming was so easy that people tried to write the program cryptic to show off. Now the programs are so complicated that you try to write it as clear as possible to make sure everybody understands your algorithm. What is an algorithm? I know you know what it is. Just put it in words, in what you understand, what algorithm is. You want to pass it?
Yeah.
Okay. A lady, algorithm?
Pass.
Algorithm? Oh, you have to participate. Algorithm? No one? Seriously? You are in second semester of programming and you don't know what an algorithm is. Nah. Algorithm? I'm going to go through every single one of you. Algorithm.
It's a step-by-step
Oh, yeah,
instructions.
slowly and loud.
It's a step-by-step instructions for a program or
It's a step. It's a recipe. What's an algorithm? Recipe of something. Done. It's a recipe. You know what the recipes are to make cake, sandwiches? Like first you mayonnaise and then you put the thing. Then, okay, that's algorithm of making a sandwich. So you can have the exact same algorithm. You cannot first put mayonnaise and then bring the cake, the bun. First you have to have the bun, then the mayonnaise, right? So they have steps. It's algorithms. So algorithm is essentially step-by-step process of doing something. And that can be done in many different things. So you get the algorithm, you can translate it to C. You can translate it to Fortran. You can translate it to Python. You can translate to C#. You can translate to Java. Same algorithm, 5 different languages. And then through different compilers, you can get the language and compile it to machine code, yada, yada. Are we good? All right. Shame on you. Bad people, the algorithm. Anyway, back to arrays. So the notation is the same. It works the exact same way. And now we know what the arrays are. We said that when you are actually using an array, really what happens behind the scene is that that array is injected inside your executable. So whatever your executable program is will contain the array in it. Therefore, when the program is running, where does the program go when we execute the program? When you actually execute the program, what happens?
It establishes a process.
Yeah, but how? See, when you're asked, if that's a good answer to a person outside of computer world. But in the computer world, you go in as much as possible in detail. So when I actually write the name of the program on a command prompt and I hit enter, what happens?
It allocates certain memories.
It what?
Allocates certain memory.
It allocates, who allocates memory?
The operating system.
The operating system allocates memory to the size of the executable, and then what happens? So let me explain. So when you actually write the program name and you hit enter, you're telling to the operating system, I want to run this. Operating system looks at the size of your executable, finds some place in memory that it fits, puts it in there, then takes the address, gives it to the CPU and say, take over. CPU goes to the beginning of your program, runs to the end of your program, and ends and goes back to the operating system. That's what happens, okay? When you create an array, the array goes into the belly of the executable. Therefore, when you actually run the program, everything, your array and everything comes into the memory. Therefore, your array is within your executable. And when your program is finished, the operating system removes the executable and throws it away. And with it, the array will go away. Are we okay with this? Therefore, the bigger the array you create, the bigger your executable is going to be. And when your program gets so big that you need lots of data in it, you want to have 5 million social insurance numbers in it, or 5 million people in it, and each one has 50 things, and one of them is a social insurance number. That's too big. Your executable becomes so big that it cannot run, okay? Then what we need to do, we need to be able to not have our array inside of executable. Not tell to compiler, hey, give me this an array with 5 integers. But rather create just the head of the array, which we know is a pointer, and let the program run. While the program is running, ask the operating system, give me this much size for an array from the shared memory that all programs use. So now you have 16 gigs of RAM. Your tiny little thing goes over there, and it has 15 gigs of place to play with. It doesn't need to be that big, okay? And Then when your program, your program switches, they can actually share the memory with other programs. How do we do that? We actually create the pointer inside our application, and when we need it, this is initializing it. Rarely you do this, rarely. Because if you are supposed to initialize it, then why even do dynamic? Just create an array. But if you actually create the pointer, and after you create the pointer, when the program is running, you request for an array of that big, that size, and then in program, it's going to happen. I'll show you in 2 seconds. And then it's going to be in the heap and not in your executable. And I said there is a big catch with this. Because you are creating the application, you are creating the array, the operating system will not remove it ever. Okay? If you forget to remove it like I did over here, you're going to end up having 5 integers in memory of your computer forever, till the end of time. When is the end of time? Reboot. Right? That's one of the good things. You can always restart the universe in your computer. Unlike us, just come and bye-bye. All right, are we good? Are we good? No reboots for us. All right? Okay, so now we want to learn that and see how it works. Okay, so how do we do that? So today is 23rd. I used to do this when I wanted to start dynamic memory allocation. This semester I changed. I used to ask students to solve a very simple program. I would say, write a program that receives series of numbers and prints them in reverse order. Can you do that? And it's a very simple task with IPC knowledge. You think. Because I didn't tell you how many. If I told you, get series of numbers, integers, or series of letters, or whatever, numbers, and print them in reverse order, with C knowledge, it's impossible. With your C knowledge. With IPC 144 knowledge, it's impossible. Why? Because you're going to say, how many integers? You need, because it's reverse order, you have to keep them all. And then start printing it in reverse order, right? You have to first get everything. You cannot just print. You have to wait for everything to, and you say, how many? I will say, I don't know. And I say, okay, so I'm going to create an array of 1,000. Nobody's going to enter more than 1,000. I'm going to say, somebody's going to enter 1,001. Then you're screwed. You say, okay, 5 million. I say, what if it's 10 million? There's no way for you to know. That's when dynamic memory allocation comes up. So let's write that program right now. How do we fix that problem? So what do I need to have? First, I need to know what is the size, right, of the array. There is, as I mentioned, there's a new type in C++ called size t. Size t essentially means when you want to hold the size of something. Essentially, it means a non-zero, non-negative value. If I say, what is the, how many students in the class? You cannot say -5. That doesn't make sense. Size of a class is always positive. So size underlying t essentially means an unsigned integer. Okay? Get used to it. So I'm going to say size t. And I'm going to say count, or CNT. Okay? What does that empty curly bracket do over there?
Sets it to 0.
Thank you. Give it to the next person. Okay, right? So again, I don't need to write. If you don't know how to set something to its default value, just put the empty thing in front of it. You're done. Easy breezy. Okay? So that's that one. And in here, I'm going to say number of integers to print in reverse order. Okay? Now I need an array for numbers, right? How do I do that? I know from the last thing that I showed, when we have an array, array is essentially a pointer with a body, right? So I just create a pointer instead of the body. So in here, I'm going to say integer pointer numbers. Okay? What does that empty curly bracket do over there? Gentleman with the microphone. What does it do? Line 6.
It's a numbers array.
I know, but what does that empty curly bracket does in front of numbers?
It's a pass.
Pass. What does that empty curly bracket does in front of it?
Sets it to the default value.
What is the default value for a pointer? Null pointer.
No.
Makes it 0. The answer is always it sets it to 0. Okay? I'm going to ask that over and over and over. Give it back to the gentleman over there. What does that curly bracket do over there?
It says 0.
Thank you. That's all I wanted to know. It sets it to 0. You good? All right, it sets it to 0. That's the first, like, these are the 10 commandments. They do that. We have that for pointers. This is the first universal rule of pointers. A pointer that is not used must be null. Must be null PTR. You should, like, if I wake you up 3 o'clock in the morning and say, you have a pointer that you're not using, what's the value? Say, no, it's not. You have to do it. It should be in your, like, you know, in your religion. That's what you, that's very important, okay? All right. The first rule of DMA. Did you pass the microphone? What DMA stands for? What DMA stands for?
Dynamic memory allocation.
Dynamic memory allocation. Remember that from now on. Okay, I never taught it, but now you know it. Thank you. So dynamic memory allocation, that's dynamic memory. So it stands for dynamic memory allocation. Are we okay with that? Okay. So first rule of dynamic memory allocation is pointers that are not used are set to null PTR. Null PTR is literally a constant. So I could have said over here this. Potatoes, potatoes, same thing. So I'm setting it to null. But remember, curly brackets are only for initialization. You can set a pointer to null PTR later. But if you want to set something to 0, you cannot put curly brackets in front of it. What is the difference between initialization and setting, sir?
Initialization happens when you have int.
No,
int
when
in
you
front.
have, you said it perfectly. When you
Declare.
are, thank you, when you are creating something. Initialization is setting when something is getting created, okay? That's the only time you can use this. So I can later in line over here, I can say numbers is equal to null PTR. I can do that. But if I say numbers is equal to that, that's wrong. You can't do that, okay? That's only for initialization. Remember that. All right. So that's the first loop. Pointers that are not used are set to null PTR. So I'm going to say over here, null PTR. Stupid. There we go. Ah, fantastic. Okay. All right? So we have a, so now back to dynamic memory allocation. I have a variable to hold the size, and I have an array of numbers. So this is essentially a dynamic array of numbers. So why they are calling it dynamic? Because it can change. Anything that can change is dynamic, right? A statically allocated array is essentially arrays that you always make. So if you are hearing somebody says, what is the difference between statically allocated memory and dynamic array? Statically allocated memory is essentially the good old arrays that you use. Okay? So a dynamic array of numbers. So now I can actually tell to, and I can see out, please enter the number of the integers, integer values. Okay? And now we are coming to another object. Cout is console out. It's an object that you can print stuff into it. Okay? Cin is an object that is console in. You can extract stuff out of it. Okay? So I can simply say over here, Cin into Cnt. Do I need to know, tell it that it's a size t? No, I don't need to. See, this is a polymorphic. This is called insertion operator. You insert into Cout. This is called extraction operator. You extract from Cin. You just write what you extract. Cin knows how to do it. It's polymorphic. Are we okay with that? Okay? All right. So as soon as I do that, now that I have the value, and let's assume that user is intelligent, which is 0.00001% of the time. Anybody who sits beside your program and starts answering your question is dumb as a doorknob. You have to assume that and then write code, even if that person is you. Okay, you have to always assume that the user that is using your program is woohoo, and then you program. Okay, remember that. Foolproof programming is for that. We're going to learn how to do it. But for now, for learning purposes, we assume that the user is intelligent. And when I said Cnt as number, if they want 10 integers, they're going to write actually 1 and 0 and hit the enter, not ten. Okay? So we assume that the user is intelligent. And now that I have the number, I can now say numbers is equal to new int 10. Oh, Cnt. So as you see, when program is running, the array is created. The next time the program runs, I have 20. I can have 3. I can have 50. Okay? Now I'm going to one by one go through the process and ask for it. So I'm going to say for size I set to 0, or I can do this. I less than Cnt and I plus plus. And in here, I'm going to say Cout I plus 1. So I'm showing their row, so they know how many. And I'm going to put a column in front of it so they know they're entering it. And then I'm going to say over here Cin. Now I know I have exactly Cnt integers. Not one more, not one less. Now I can say get into numbers I. Oh. And I'll keep going. So one by one, it's going to receive the numbers and put it in the numbers. And then I can actually say Cout. Now I can print in reverse, right? So I'm going to say void prn reverse integer const integer pointer nums, right? And obviously I need to know how many they are. So size t num or Cnt CNT. You're looking at your quiz, by the way. Your quiz is going to be something like this. I'm going to ask you to write this for me. All right? So now I'm going to say, and let's do it comma separated. So I'm going to print comma separated in reverse. So I'm going to say for size t, I set to 0, I less than CNT and I plus plus. So I put. So I'm going to say if I is not equal to 0, right? See out a comma. So if it's not the first one, I think that's correct. We'll find out. Print a comma. Then I'm going to say see out nums I, right? And at the end, I'm going to go new line. Okay? So instead of that, I'm going to say PRN reverse and I'm going to say numbers. It's the empty. Okay? I'm going to first run, then ask questions. And why I did this, why I did that. So be aware of it. Now, one thing is missing over here, and that is I said I am creating these, so I need to remove it. When I do not need the numbers anymore. At the end of main, right? At the end of main, I don't need this anymore, correct? So that's where I'm going to remove them. Removing them is called delete. So in here, I'm going to say delete. And exactly you delete how you create. If you create an array, you delete an array. Okay? You will learn soon that you can actually create one individual thing if you want. You can create one integer dynamically if you want to. Which means it's not an array. You can just say integer pointer a is equal to new int. Done. It means one integer. If it's one integer, you don't need the curly bracket. Okay? So in here, I'm going to say numbers, and they're all gone. Now, if I run the program 3 years later, 4 years later, anybody's telling me you were supposed to print in reverse? Am I printing in reverse? No, I'm not printing in reverse. What the heck you're doing? CNT minus 1, right? Minus 1, I greater than or equal to 0, and I minus minus, right? Now, if it's not equal to CNT minus 1, I think that's reverse now, right? Hopefully. We'll find out, okay? So we run the program. Now in here, enter a number of integer. I'm going to say 3. Okay, when you're testing a program, you usually do 3, right? No, don't say like 55 and test it like that. Put small amounts, see if everything works, then you can go with bigger ones. So in here, I'm going to say 10, 20, and 30. What did I do? What did I do? What did I do? Anybody tell me what did I do wrong? Why it got infinite loop? Should I put a price for it? You have the information, all right? I tried to play it smart, but playing it smart kind of made me shoot myself in the foot. Why? I can only then, go ahead. You just earned yourself 1% for midterm. Okay? So he's right. I put size t. I said size t is only positive values, right? When can this condition go wrong? When I becomes negative. Can it be negative? No. So the values inside a variable, for those who don't know, are always a circle in any programming language, which means when you put a value, it's like that. Always. This is 0, and this is max. Always. Or minus max and positive max. In our case, we have 0 and max. So if I go backwards like this, it comes and reaches to 0. When you go 1 below 0, what happens? It becomes maximum positive. And you keep doing that over. And the reason that it stopped, I think I crashed something. I don't know. Something went. I went a billion times printing something. Right? Right? So how can I fix that? Can anybody tell me? One easy way is to get the heck with it. I'm going to remove the size t and go integer. Like, you can do that. There's no problem with that. So one way is to actually, when we have problems like that, and the reason that I always do this, and you see that I write the program, I make a mistake, I want you to actually see what happens, and then if it happens to you, you can fix it, right? There are two ways. Either remove all the size t's and make it integer, right? Well, for that, you need, if the program is really foolproof, then you need to put a certain type of validity check and stuff like that. Another thing is to go one less. So I'm going to say while it's greater than 0, right? I'm going to bring the size t out. So another way of fixing it is like this. I'm going to bring this out. So it's not going to be so it's not going to be a block scope variable. When you put the size t inside for loop, afterwards, it doesn't have any value, right? Or let's actually, yeah, that's one way. And then, so what happens? If I do greater than 0, this is going to stop when it becomes 0, right? And ends. So what I can do afterwards, I can print it one more time, right? I don't know if it's going to work. We'll see. Probably it's not going to print the comma for the last one. Right? Which means then I don't need to write that if statement anymore. Right? But if it's 1, it's not. Anyways, let's let it be. So in here, I have to put a comma in here. Right? And I hope it works. We'll find out. So I'm going to go 3 again. Take 2. 3, 10, 20, and 30. And I have 30, 20, 10. Yay! OK? So it actually shows. And now I can run it again. Now I can go 10. Now it's going to be 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100, and 200. Fine. It's going to be in reverse. So it doesn't matter how many things I have. It's going to keep going over and over and over. Are we OK? All right. That's dynamic memory allocation. As easy as that. But again, I can make it more challenging. I can say, don't ask the user how many, and detect how many they are entering. OK? We can do that too. Well, we need a little bit more. But you can, well, every single time you have more, you have more, you have more, the guy's going to go crazy, OK? Or there are other ways, but you can always do that. But then you need to learn how to resize and stuff. But this is like the very beginning of dynamic memory allocation. There is nothing else to teach in dynamic memory allocation. That's all. But it becomes so complicated, you will see soon, that it's like I just told you, OK, 1 plus 1 is 2. Now go build a rocket. OK? So it's not, you can actually go much more than that. So having said that, let's, now that we understand what dynamic memory allocation is, let's actually take a look at it with the kind of, let me just, went to the wrong one. I'm going to my previous ones to bring the slides for it. Okay. Time? 53. We have till 12:30, right? Or 12:35? 12:30? Okay. So really 7 minutes break. Let's not make it 8, okay? We'll be back at 12 o'clock. I'm going to turn off my microphone. You're responsible to tell me to turn it back on. Otherwise, the other half is not going to have audio. Please, thank you. All right, a question came up. Why you don't have end L in here, but you have end L here? So end L essentially means new line. It's like \n, but it has one more thing. Okay? Now, this is something that's going to be a little difficult. I just want you to please listen to me, okay? When you are on your computer, it's you and your computer, correct? And you are running a program, you are the master, you are writing something, you tell the thing to go to new line, and it goes to new line, and so on and so forth. When you are in a multi-system like Matrix, hundreds of people are connected through terminal to Matrix, and many, many things are happening. It is very expensive. What is the meaning of expensive in computer science? It's not money. So I apologize. It is with microphone talks, and if it doesn't, they say pass, and it goes to the next one. And memory is not very expensive anymore. Memory used to be. Now, for like 20 bucks, you can get 16 gigs of RAM. Time. Time is the most important thing. Okay? When you are on your computer, printing on your screen is just printing. Well, when you are on Matrix, printing essentially means sending information over internet to your computer receiving and showing it, right? So imagine every character that you print has to be communication between server. That's crazy, right? Because of that, most of the information that are printed on your terminals, even if you are local, it's now written as if you're not, which means not everything that you print actually gets printed on the screen. It gets printed when the computer is good and ready, which means there are no other important tasks happening. And L is asking the compiler to the system, show it now, and go to new line. If you just put \n, it's possible that you are asking the user to enter something. And it's very possible that you don't see please enter a number of integers, and then I wait for you. It's possible that it's not going to get printed, shown. Okay, it's not going to happen, but that's the case. Like especially if you create a progress report. Have you seen those things? 2% is done, 3% is done. It keeps rotating like that. If you don't do end L after that, its process is going to happen. Suddenly you're going to see 100%. It's not going to show all the things to you. Okay? So that's what it is. So end L is not only new line, but it's flushing the buffer onto the screen. Okay? Be aware. But for in our pay grade, NL is another word for new line. You good? All right. So let's quickly see how dynamic memory allocation works. When you are doing dynamic memory allocation, you have a type, you have a pointer, and you always set it to null pointer. Something that I did not do when I said the rule of the rule number 1 of the thing to have unused pointers set to null. I didn't do it. When you always have to nullify. my mistake. I didn't do it. There is something that is actually a debate was going between us professors about how to teach you guys. And they would say, okay, why you are telling to students not to use break and continue in the code? Why students are not allowed to use multiple return statements in a function? Many of you do that, right? In my class, if you have 2 return statements in a function, your code is resubmit. 1 point of entry, 1 point of exit. That's religion to me. Okay? You are never allowed to use the word continue ever in your life when you're in my class. Okay? Break is only to be used in switch statement and nowhere else. Why? Because we abandoned that 40, 50 years ago. It created spaghetti code. We had go-to statements. You could jump from place to place with no condition. And it was making the code sloppy and impossible to debug. So they said, from now on, okay, let's just do go. Those things that cars go 300 kilometers an hour. First, you have to learn to drive. You need to know the rules, understand the rules, so you can know how you break them safely without killing yourself. Okay? So, because you're all babies now, no break, no continue, no multiple return statements in my class. When we go to 3, 4, 5, now I'll explain to you when you can have multiple return statements and it's safe to do so. So you understand the precautions. Me, myself, decades of programming in C++, still I don't do it. Because many times I got too confident and I did it. And create bugs that I had to run after that bug for 3 years to find out what the heck is wrong with this damn code that every 6 months suddenly it breaks and then another 6 months it works perfect. Okay? So these rules for me is your rules that I think should be followed. But computer industry says, hey, come on. Yeah. Until you understand how it works. Anyway, so one of those rules is you always keep unused pointers as null until you understand when you don't need to do so. Okay? So for now, please, at any moment you have a delete afterwards, set the pointer to null. For now. And by the way, deleting a null pointer is okay. But deleting a pointer with some number in it with no allocation will crash your program because you're literally asking operating system to remove someone else's memory. Any number is an address. We know that. But if you have an allocation, that place belongs to you. You're allowed to delete it. If you have just some random number and you delete it, it might be some process in operating system. They prevent you. They literally say, the message, you will see the message, believe me. You're going to write code and you're going to see the message hundreds of times on matrix. Segmentation fault. Whenever you see segmentation fault, it means you try to access or delete some piece of memory that is not. So anyways, the pointer is created. It has some garbage value. You have to always set it to null. If you try to access, so if you try to set some pointer or something to a value it's not setting, it's null pointer assignment and it's going to crash. Don't use it until you allocated memory. Number 2, when you do dynamic memory allocation, always stay within your boundary. It's a very common mistake to go 1 extra in your array. It's a crazy thing to catch. So that limit that you're going, it's 10 characters. Because you put 10 over there, you go to index 10. But index 10 essentially means 11th. Therefore, you crash your program. Remember that. Delete when you're done, not to have memory leak. Not deleting will not crash your program, but leaves garbage in memory. And that's one of the worst things that can happen. It reduces the computer performance as it goes through, and then you have to reboot your computer to gain access again. Okay? When you create a pointer, make sure you set it to null so you know there's nothing in it. Otherwise, there's no way to identify it. If you actually access it, it's going to crash your program. Okay? Allocate using new statement, and you put the type in front of it. When you allocate with no brackets, is your one. Therefore, good. Or even you can use array notation. Perfectly good. If you go one further, it's going to fail. And you delete exactly how you create it. If you create an individual one, you just put delete. You don't put brackets. If you put brackets, you're saying delete many things after. You don't want that. And if you do reverse, you create an array and you don't put the brackets, it only deletes the first element and the rest becomes memory leak. So remember, any way you knew, that way you delete. Are we good? Are we okay? Again, when you create, don't use first do dynamic memory allocation. Always set to null and keep track of what is the size that you have. Have some kind of a logic to take care of the size of the value you are allocating, unless you don't need to resize it. You have to some constant value for it. But size is something that is always important. Within, whenever you are resizing your memory, remember not to just allocate new one without deleting the old one. That is one of the main reasons for memory leak, because you keep creating new memory, and every time you're overriding it, the other one is lost. Always delete it first, not to have memory leak. Correct state of an unused pointer is always null pointer and the size set to 0. And when you allocate memory, always keep track of what the size is. Make sure you delete after you're done. And afterwards, set everything back to 0 and null. Always. Make sure you create, you delete the way you create. If you have an array, you delete it without square bracket, only the first one gets deleted, and the rest is memory leak. When you are reusing pointers, see if it's not null. If you follow the point religiously, then you can always check to see if something is null or not, and then you can identify if there is data in it or not. And then after you're done, you can delete. But you don't need to check for null to delete. Null, delete has that mechanism inside. So you can easily delete a pointer. If the pointer is null, that delete won't do anything. No harm. You don't need to. I see lots of people say, if not null, delete. You don't need to do that. It has that mechanism within its belly. And then you can reuse with new size and spec. Always stay within, and you're going to be good. So having said that, let's write this code so we do this over and over. So I'm going to put this thing in a loop. So now what I can do over here is this. I can say do and in here I can say while. whenever something like this happens, I don't go through what the condition is supposed to do. Whenever I have something like this, I'm going to say Boolean done. Or you can say equals to false. Sorry. Right? If I just put empty curly brackets in front of it, it will be false. So I'm going to say do while not done. Now, whenever I want to end, I'm going to set the done to true. Like that, you don't have to write 50 conditions with and or and stuff like that. Just set the condition and set it to done, and you're done. Okay, that's the easiest way. So I enter the value. I do the thing, so this is fine. It's getting it. It's allocating it. It's printing in reverse. And deleting, then numbers set to null PTR. Okay? Now I'm going to say if yes, is that a good thing to write? Yeah. If yes, and the message is going to be continuous. So I'm going to say if yes, continue. Now I don't need to have that done. See, I just thought of writing a function called yes that returns true or false if user actually says yes or no. So I do that. So I'm going to put this one, take this one, and put it in here. And I'm going to remove that. So now I'm going to write a function called yes. Boolean yes constant character pointer prompt. And I'm going to write that code. This is how you program. Procrastinating programming. That's called procrastination. So what you do, whenever you see, oops, how do I do that? Write a function for it. Write the code. So believe me, I can actually compile this thing. Without even writing that, I can actually compile this. See, I can come over here and say compile. Success. I didn't even run it. It means logic is sound. Of course, if I want to compile it, linker is going to tell me what the hell is yes. I don't have yes, right? Okay, so now I'm going to write the yes over here. Again, in here, I'm thinking user is sane. So I'm not error checking, all right? So in here, I'm going to say cout prompt, okay? And then I'm going to say yes, no, and I'll do like that, and I'm going to prompt and go. So I'm showing the prompt, and I'm going to say yes, no. Okay? Then in here, I'm going to have character response. That is set to null. Okay? Now I'm going to say response is equal to cin response. Okay? So it just receives one character. And that's it. Okay? And then after that, I'm going to say if or return response being equal to y or response being equal to lowercase y. Right? Done. Okay? So now I can run it and see if it works. And if it doesn't, so now, as you see, that dynamic memory allocation keeps going and going and going. So the array gets resized over and over and over and over as my program is running. So I don't know if it's going to run or not. We'll see. If it needs to get fixing, I'll do it. So enter a number of integers. I'll put 3. Oh, 3. Okay. 10, 20, and 30. Continue yes or no. I'm going to say y and hit enter. Please enter the number. Now I'm going to put 4, 30, 20, 30, 40. Continue no, and it gets out. Right? So programming is like that. Easy. Try to always create functions, whenever you see the complicated thing is happening, use your imagination. The thing that you want to do, the information that you want to take care of, those are the arguments of the function. The results you want to get are either return value of the function or the things function print. Keep using coding like that over and over. Okay? Now, and it's deleting it's going over this. So, yeah. So that's that. Any questions down to this point? Suggestions? Yes. Aha. Should we delete before or after setting to null? The answer is this. So this is your pointer, okay? And this is the memory that it's pointing to. If you set this to null, what happens? Okay, that's it. Okay, so I like that I got it. Now, this is another assignment that I want to ask you to do. Go to, I don't know, dollar store has it or not, or someplace. You see, you know those 4-colored big pens? Bic actually should give me a percentage on this. Those 4-color thingies, you need to have one. Anything you do in dynamic memory allocation, you draw. If you think you can imagine it, prepare to fail this object. No one. You can imagine dynamic memory allocation and do it in your brain. If you are a genius, and definitely if you were that, you were not here, you would just be making billions right now somewhere. Okay? If you are in this college to learn, you need that 4-color thing. Yeah. See, there is an So he was asking, should I set it to null, delete, or the other way? Okay. So what I'm saying is that if I'm going to answer it anyway. So if I want to delete this, if I first set it to null, this is what's going to happen. It's going to get set to null. Now if I say delete the pointer, how does it know where the memory is? Right? Okay? So the whole point of setting something to null is to mark it as this is unused. If you make it unused before deleting, then delete is not going to do it. But thank you for the question. Okay? Now if I actually work it properly, which means if I actually delete it, so first I have this, that's supposed to be an arrow. When I have this, when delete happens, delete knows where it is, and hopefully you put actually some array. So the very first thing happens that this is deleted and given back to the operating system. So this is gone. And now that it's gone, that arrow doesn't need to point to that piece of memory anymore. Therefore, now you need to actually set it to null. Are we okay? Questions? Suggestions? Objections? Okay, so we are down to this point. It's 24. Oh, clear all, do that. Seriously, I know, you blocked my ads. Thank you. All right, so what do I... Okay, so we are at the end of dynamic memory allocation. Again, by no means it's completed. Go through it, make sure that you understand everything and any bit of it, and if you don't understand, next time you come with questions. But next time you have a quiz on this, so Okay, be aware of it. I'll tell you if the quiz is programming, I'll tell you what the question is going to be. So I'll tell you your task for the quiz that you're coming in is to write this and that and that. And I'm going to ask questions of the same thing. I have no backtrack for questions. If you have 3 questions, you do the next one. Prepare. Can track in my tests. You answer that question, you go to the next one. If you don't know the answer to it, gracefully go to the next one because that's more mark. If you answer something incorrectly, you just piss me off. Okay, don't do that. No random answers. We'll kind of you'll see exactly what I mean. So just make sure not answer incorrectly. I hate flip of a coin for answer. That's why I don't want reference sheets in my class, in my tests. I don't, because reference sheet always, this looks like a right answer. Let me just put it over here if I can get a mark or 2. The first rule is that if your answer is not exactly answering the question, there are no partial marks. But if you try to answer the question, a single semicolon will get you marks. So try to answer the question. If it's incorrect, but you're trying, you may get 90% of the marks still. But if your answer is not, if I ask you to create a structure for a student, you create the perfect structure for a car, you get 0. Does that make sense, everyone? I think that's fair, right? So, have a beautiful day. Let me stop the recording. And first of all, I have to push the stuff. Give me a second. Let's go. 12:30, the next class starts. 12:30, we're done. 12:35, the other one's done. Okay. If somebody checks, I would really appreciate it. 12:30 starts or ends? Yes, thank you, thank you. So I have time to pack. Okay, thank you. Sure, anything, or you can send it to go on team and send me. No, audio, come on. Add it to the attachment, you can. Trust me. If it doesn't, then let me know. But I think you can.